Hi, I am Lokesh Jha. Welcome to JavaScript Part 5, the final JavaScript video. After this, we will be starting React. In parts 1 through 4, we covered variables, DOM, loops, and functions, arrays, objects, closure, classes, error handlings. Today is the piece that ties everything together for real world development. Async in JavaScript, that is how you fetch any data from server. So let's suppose you have a front end, you are just refreshing a page and some data is popping up there. So how that is coming from the server, how the JavaScript is taking the response from server and bringing it to our screen. So we will see all those things, how the API calls happen, load user profile, and get the weather data, submit forms, everything that happens in real application involves async code. So we will cover how the JavaScript handles async code, callback, callback hell, promises, async await, and the fetch API, error handling, and async codes. So we will be covering all those things. And at the end, we will be going for the real project. We call an actual live public API, fetch real data, and display it on a web page with a loading state and error handling. So this is the first section that we will be covering, and here we have sync and async. So first we will be going to understand how the JavaScript works. So before we understand async, we need to understand how a JavaScript code normally works, how it gets executed. So JavaScript is single threaded and it executes the code line by line. So when the JavaScript is running console.log step 1, it will execute this, it will print it, then it will go for the next line. It will execute this, then the line will be printed, and similarly the step 3. If these three lines are only there, it will be lightning fast and you will see the logs here that okay, we have these steps printed. But what if we have something here that needs to wait? So something is written which is fetching something from server, and it will give a response that okay, this is your data which you asked for, but it would take something like 1 second. So JavaScript needs to wait it here. So it will wait that okay, just give me the response and I will print that. Then I will go for step 3. So this is single threaded behavior that we see in JavaScript. What does single threaded means? That let's suppose there is a CPU with a thread and you have a task to do, and it will just point to one task, it will complete this, then it will go to the another task, it will complete this, then it will go to the this task and it will complete this. So it's like one thread is only there which we have to utilize in order to execute any code. This was the example that we saw the synchronous behavior of JavaScript, that it goes in synchronous, runs in order, one line at a time. So this is the very basics thing that JavaScript does. Yeah, now we have a problem if we state that we have just console, and imagine this line is going to take 5 seconds, then it will just block everything. We need to wait for 5 seconds to just execute this thing. Now this line and this line is very simple. These are not taking any like kind of good amount of time that will be visible to users, but this line is printing very fast, but it will be waiting for this line to execute for 5 seconds and then this line will be printed. So we will see a delay in response here, and similarly this will be also delayed even how this doesn't need to wait. So how JavaScript will solve this problem? So how we see this problem? So currently you are just thinking that why we are so concerned that if even if this line is going to take 5 seconds, then why do not we wait to just execute and we just print this thing, that after, even if we print this and then print this and then execute this, anyhow it will take 5 seconds. The simple understanding is that okay, even how we need to wait for 5 seconds, then why we are so much concerned that we need to execute it fast, or something like, okay, this needs to be executed first. So let's take an example. Instagram, you open the app, you have some feed here, which is kind of reel, and you have likes and all those things. So let's suppose this is like, this is comment, and you have reel here. Now you are scrolling and you see that, okay, there is a delay of 2 seconds for each video. However, if you are a developer, or if you are let's suppose you are the CEO of Instagram, and you just figure out why this is taking 2 seconds, and you got to know that the like count is needs to be fetched, the comment needs to be fetched. So that's why we are delaying the response here. So what could have been better? You are a user and you know that the first important thing is the reels, the content. You just want that, okay, I need to see the reels, then if I want, then I will click on comments, and the comments needs to be loaded, and I will see the comments. The first thing is this reel is important. So the here reel first, then comments. So we will be loading this and this in parallel, but we should not wait to load the comments, then we will show reels. Reels should be displayed as it's loaded on the screen, and we will load parallelly the comments. Now you see what is the problem we are trying to solve. We are trying to deliver the content to the user as soon as possible, and we will be also loading the contents which could be delayed for a while, not for like 1 hour, 2 hour, just for 1 second, 2 second. If the user is not much concerned about that, we will be prioritizing the content which is more important, and we need to show that, and this could be done in parallel. But the JavaScript we saw has a single threaded, and also it waits to execute the first thing. It will wait that, okay, reel is there, then it will go for comment, then it will go for likes, something like that. So if that is the kind of scenario, then why JavaScript is so much popular? Since you see that, okay, React is the framework which is used popularly, and Node.js is the platform for the backend where it is used mostly, and JavaScript is the language for both. So because we have something which solves this problem, that is async. So we will see the async. First we need to understand what is call stack and event loop. These two things are very important. So now we will understand what is call stack and event loop, and we have already covered this, but again we will cover this point here in this video because this is important. And we have a context window and we have a call stack. What is stack? Stack is a kind of data structure. So what is data structure? So how we keep, so you know that, okay, variable a where a equals to 32, and if we want to put a array, then we can do 32 comma 3, sorry, 2 comma 3 comma 4, like this. And this is a kind of data structure to store multiple values in one variable. So this is array. Similarly, stack is there. In a stack, what happens? You just put anything inside, so it will be here, then you put something, it will be here, then here, like 1 2 3 4. And you want to take out, then 4 will be coming first, then 3 will be coming first, then 2, then 1, and now this stack is empty. So this is stack. And queue is you put something, so it will go here 1, then again you put 2, then 3, then 4, then 5. And you want to, so just remove anything, then the first item will be removed, so 1 is removed. Then again you are removing something, 2, then you are inserting something, 6. Remove, 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 remove. Now the queue is empty. So this is first in, last out. Philo, this is first in, first out. Whoever comes first, that only goes out first. So this is queue. How you see, as the name suggests, in a line, when there is some counter, whoever is first, that gets the ticket and it goes away. Then the second, then the third. So this is queue. And the stack is how you see any, if you are, let's suppose you have kind of drum and you are putting something inside this, so whatever came first, that will be withdrawn at last because some things are on top, so that's why needs to be removed. So this is stack kind of data structure. This is nothing but kind of so what you see as an array, 1 2 3 4 5. So similarly this array, if we force that okay something will be inserted here, and if we want to remove, then that will be removed from here only, so it becomes stack. And if we force that okay something is inserted from here and it will be removed from here only, then it becomes queue. So in simple words, we got to know what is stack and queue. Similarly, we have stack here, and this is web tools, or we say web API. Now here we have, so we have callback queue, and we have priority queue, and we have a loop here, that is event loop. Now in better picture we have this. So this is your call stack. Means, so whenever you are, let's suppose you have a main function here, and it, so you have called your main function at first, so it came here, and now it's executing this, and the main function will look like this, and console.log, and we have main called. So here we are calling main function, so this main function came into the context. So here we have context. Then in the main function, we see that okay, logger needs to be executed. So it came as logger, then console.a. So whatever needs to be executed, it happens like this. And in more detail, if you see, so right now you you will see this context like this. You have main called. Then now we need to execute the like execute this function inside this, so we will have a context inside a context, and here we will have logger and all. If we have another function inside this, so again we will have a context inside context inside context, so like that. And here we will do the execution of that JavaScript. If you are thinking why do we have box into box into box, then as either you need to go into the previous videos to know what is lexical scope, or what is scope, at least you need to know, then you will understand why we have boxes here. So this call stack here will have those context of this that need to be run here. So the context will be here. Okay. To understand the context, we will see some line of codes. And let's suppose this is function, this is function, this is a variable. So JavaScript will start reading from here. It will see there is a function. It will put it here. Again, it will see a function. It will put it here. It will see a var. It will put it here. So it will just put everything here. Whatever it is in the main heading. If there is something inside a function, so it will be also here. But if we do something constant, function s equals to full function, then there is a difference. So let's see that also here only. A normal function and a fat arrow function. What happens when you write a function like define name, and you write full function of like 4 to 5 lines, or let's suppose you have written 10 lines. So this whole code will go inside the context. So where is, what is context? So it is of course RAM. It will take this much of space in the RAM. So if you are running in your laptop, it will take this much of RAM in your laptop. If this code is running in server, so in server's RAM, this much of code will be taken off. Okay. And let's suppose you have this much of RAM, and your function are occupying this much of space, and you will at least need something this much for your variables and some calculations to be stored and all those things, or whatever the API response is coming, and you have this much only RAM left for some variable works. So it will be getting choked if some other functions are loaded or something is happening. So that's why we will see what is fat arrow. So we have a constant definition equals to like this here functions. As we have defined a very function with const or let anything like that, we are defining any full function with a definition of looking like we are defining a variable. So this just stores that okay, we have a variable named definition in the context, and when this will be called, then only this whole function will be coming into picture in the RAM. So it will save the space. So in the context, if we have fat arrow functions, only the definitions of that those variables will be there, not the full function will not be there. So this way we are optimizing the space in the RAM and we are saving some memory. So this was not in the context of understanding sync or async. Just I've added something that okay, that you need to know what happens when we use functions or what happens when we use fat arrow functions. As uh, after the introduction of fat arrow, we are using this to of course optimize the space occupation. Now we have context and we ran some function, so that will go into the call stack. If for this execution we need another thing, that will come here, and for this we will need another thing, so it will come here. As in the main we have logger, and logger is console.log a, so this will stack up, stack up, stack up, and when this is executed it will be removed, then it is executed, it will be removed, and it will be executed, it will be removed. So this is call stack where JavaScript codes are executed. Now let's suppose you got something as API call to server to get the match score. Now this will be not in call stack, as the JavaScript says that this task will take time, so that will be shifted to web API. Here the Chrome or whatever browser you are using, that will be having the API call, and it will wait till the API response is back. When web APIs will know that, the browser will know that okay, I got the response, it will push into either of the queue. So now we know both of the thing, queue and priority queue. So the task will be pushed into callback queue or priority queue as per the what event they are. So it depends on the event. So promises are given much higher priority to the priority queue. So if there is something in the priority queue, that will be consumed first by call stack. So what happens? Let's suppose this is callback queue and this is priority queue. We have promises and your event loop is here and your call stack is here. There is one item. Event loop will have a look always, it will be looking at this call stack, as it will see that okay, this item is done, it is emptied. So now call stack is empty to take new task to be placed at that point. As you know, the JavaScript is single threaded, so that's why it does that kind of work, that it takes a task. If it is going to take time, it will just ask event loop to push into a web API, that will be in web API. When this will be executed, then it will push into either of the queue by its priority. Then event loop is responsible to always monitor this call stack, this priority queue, this callback queue. If it see that okay, callback queue is callback stack is empty, and there is some material in priority queue, it will pull it and it will push into this stack and it gets executed, and then it takes from callback queue and it again puts into here and it executes. So now JavaScript had only a single thread. Any task came, it executed it as that of time. If another task that is going to take time, it will go into web API, and event loop will know where it needs to be pointed. It will have all the details where it needs to be picked, where it needs to be dropped, and all those things. JavaScript itself will just go for another task and will pick if that also going to take some time. It will be pushed into web API. If that is kind of sudden synchronous thing, then it will just execute and say, okay, you have this. So this was the event loop and call stack. So now you have a picture of how this call stack is executing. This web API is helping JavaScript to wait till the API response or whatever set timeout or any fetch thing is happening. It waits for JavaScript. Then it is given to a priority queue or lowest priority queue as per the label, and this is consumed by the call stack by the priority. First this, then this, then this, then this will be consumed. Also, you might come across a name, the starvation, I think starvation uh, loop or something is there, where this priority key is always full and it is consumed and executed, and the older events in the callback queue just starve to be consumed. So it just wait here till this queue needs to be empty. After that only this will be executed. So in interview you could be asked that explain JavaScript event loop, and you can answer JavaScript is a single threaded and use a call stack to execute code. Async operations like set timeout and fetch are handled by the browser's web API, and when they complete their callback, go into a callback queue, and event loop is constantly monitoring the callback stack is empty. Then it needs to move the events from the callback queue to the callback stack, and that will be executed. So this is how JavaScript handles async operation without blocking any. Here we'll have set timeout and set interval. So here we have set timeout. If we have consoled something and we have a point timer that okay need to execute this after 2 seconds, and we have added a console before and after. So what will be the output? So it will be printed before timeout. Then this will be just going into the call stack will see that okay this needs to be having a waiting time, so it will be shifted to web APIs, and JavaScript go for the next. It will not wait to execute this, it will just go to this. After timeout setup will be printed, then this set timeout response will be coming after 2 seconds. So if we just see how correct we are, just JavaScript, then 7 and node set timeout. We are waiting. Now it printed after 2 seconds. So this is the set timeout. This is set interval. It runs repeatedly at intervals. We have given interval ID, set interval, and count plus plus. Count is defined outside it, and we have given count plus plus and console the count. If the count is 5, clear the interval. So here we are clearing the interval and consoling that okay stopped. Now if we run this, of course that the above code will be printed. Now if we run this node set timeout interval js, we have 1, 2, 3. After each 1 second interval, we have seen this and it is running. So we have cleared the interval and it is stopped. If we want that okay the delay could be something like 2 seconds, so it is happening like that. Now we got to know that okay this you need to comment this before running the below one, and the we have seen that okay we console this set timeout will go to the web APIs, then it will be printed. If we again copy this one here to see that what happens before tick, and we print this. After tick, we commented this, save, run. Before and after is here, then tick 1, tick 2, tick 3. So whatever needs a wait of the time will go into the web APIs and other codes will be executed. So this was executed, and after that, these 2 seconds interval things are happening. So this was set timeout and set interval. Now we will see what is callback and what is callback hell. So first we need to understand what is callback. So a callback is simply a function passed as an argument to another function to be called later when something is done. So and we have already used callbacks in for each map, filter, and event listener. So it is something like uh, we want that okay, you need to have a function and we are calling this function by some parameters and we are passing function itself. When these things will be called, just call this function. So it's like that. We are passing a function itself as a parameter, and when some things are done, you need to call this function. It will be written something here and this will be executed. So it's like that. For example, we are calling a API. If you get all the data, just call this function which is responsible to show this data on UI. So this is how related and how we can render some stuffs on UI. So you know already the callbacks. Here you see 1, 2, 3 dot for each. It could be addressed here also that 1, 2, 3 as array and array dot for each nums and fat arrow as console.log nums. So here this is a callback as on this array after each element just call this function. So it's not a function but yeah we can save it as a function something like function name curly braces and just console.enum we will be giving you num and just function close. So it is just a one liner function. So that's why it doesn't look like a function, but yeah, we are consoling something. So it's kind of example of callback. Now we have already seen btn as a button dot add event listener. Whenever some click is happening, an event is happening, or whatever here it is a event or some calculation or anything execution of code or something is happening, we need to do this what we were doing something like submitting the form or uh, doing some pop-up or anything. So we are adding a event listener, so this is callback. So if we see a simple callback example, then function, here we have do task and task name on complete. So this is a function. If we see what we are doing, we are consoling starting task name, we are giving the we are starting a task name, then we just simulate by having 1 second of timer that we are doing some work. Just it's called mimicking work. Let's suppose that work used to take 1 second, so we are just giving a timer that okay, after 1 second just print that done task name, this task is completed. And here we are writing on complete and give task name. So we executed everything and at last we have called this function which we got from the parameter and do task download a file result console dot. So here we are this function was called and we were passing this. So here this task name was passed, result is here, console.log callback received result. So we called this function and we passed a function also. This is called callback. So when we call a function with a function in parameter, as after done something, the function needs to be called. So this is callback. So here we do not have a control to stop or check anything. It is just written in code that if 1 to 2, 2 to 3, something like that. If this is done, do this after that. So we do not have any control here. Now, what is this looks simple that okay, we are having some function, we are passing that function to some other function. If something is done, then we will call the third function. So it looks good. Then why we have a term called callback hell? So I hope you understand what is callback. If don't, just comment below. I will give kind of notes so that you will understand that. And we have callback hell. So callbacks work fine for one operation or two operation, but in real apps, you often need to have multiple async operations and in sequence, one after another. So there, the callbacks get messy. So let's suppose you have some task that after one you need to execute two, then after three, then four, then five, then six. So you have a kind of series of things that need to be executed after each execution is completed. So here the callback gets messy. For example, callback hell is like giving someone direction verbally, but each direction depends on the previous ones. After you pass the red building, then if the signal is green, then go left. Then after the second light, traffic light, then that. If the person goes off by any one of the direction, everything is gone. Each step is nested inside the previous one. By the fifth nesting levels, nobody can follow it normally. So, as I drew it like this, similarly, when you code a callback, it the code grows horizontally, and it is little bit weird and hard to read and understand. But the other thing what happens is, suppose you have something needs to be changed here. If you make something change here, things will break below. So you need to take care this also, this also, this also. Then it becomes hard. So it is not easy to maintain and understand. You will just write all the codes, and the person who wrote it will understand that moment. And after like 1 year, he will also not have the idea that what he wrote, and then it will become more hard to debug it. And also, yeah, debugging also issue here in the callback. So that's why, because of these reasons, it is called callback hell. And after that, JavaScript introduced the async and await, which we will be looking for. So in the interview, you could be asked that what is callback hell and how do you avoid it. So you can answer that callback hell occurs when multiple async operations are nested inside them, like each other, as callbacks, creating deeply indented, hard to read, hard to maintain code. And it is also called the pyramid of doom. And it it could be avoided using promises, which allow chaining with dot then, or async await syntax, which makes even it look good and easier to maintain. So the first was callback, then we have dot then, that okay, after this, then do this. Okay, after this, then do this. So it is a pattern, but the best is async await. That is practiced mostly in the industry right now. So this is callback and callback hell. Now we will go for section 3, which is promises. Okay, promise is something which you do with a friend that okay, just give me 5 rupees and I will return you after 2 days. So now you have a promise, and after 2 days, you will get the return. Then you see, okay, the promise is completed, or he will not return it. So promise is rejected. He is not returning the money. So promise is an object, and that represents the eventual result of an async operation, not the result, but eventual result, that okay, this will be giving a result. So you can just take this promise as the result, and it is a promise that you will get a value in the future, either successful or with an error. So you can just keep it. In future we will get it, the value, something value will be there. So for another example, a promise is like ordering food online. When you place an order, you get an order confirmation that okay, you have a confirmation, the food will be uh, at your doorstep in 3 minutes, oh sorry, 30 minutes. So it will have some success of pending to fulfilled or rejected, that it might be that okay, the restaurant has rejected your order and it will be cancelled because of the rejection. So this is promise. So promise has three states. First is pending, another is fulfilled, rejected, and you do not need to be worried. I will be adding all the notes in the GitHub. uh, the link will be attached for the GitHub where we the notes could be found, and all those codes that we are coding here, that will be available here. Now let's make promises.js. So we have defined the three states of promises: the pending one where the initial state is there, result not known yet, operation completed that is fulfilled, and operation failed that is rejected. So how do we create a promise? So we have just a simple definition that we just take a constant my promise and we write new promise, and here we have resolve or reject. These two things are there, and async work is here. So just we write success equals to true, and if success is true, just write operation succeeded, else we will reject it and we will write something went wrong. So this is kind of just mimicking that okay, how a promise will look. And if we right now call a promise and we write dot then, so dot then means after execution of this we will do this. As we saw that okay, we could have a callback. So right now we will have dot then, that okay, okay, how we have that dot then executed. So my promises, sorry, my promise dot then, we have result, whatever the my promise will be giving, that will be coming into this result. We are consoling that console.success, we have a result. As it is true, so the response will be operation succeeded. And we have catch, if something goes wrong, there will be some throwing error or something, it will be catched here. And this is a finally block that will always run, as we have seen what is try, catch, and finally. So we have this here. Now if we want to simulate the real example, so this is here. So let us write a realistic example. Here we have get user data. It is a promise here, and we are consoling that fetching user data, and we have given a set timeout. Just we are checking that okay, user ID is greater than 0, then resolve it, ID this, and name and email. We are just making anything, and we are taking 1.5 seconds. And if that user ID is less than 0, then we are just rejecting it. So now here we have 1, so it will be giving the response of this. If we put -1, then we will be getting a reject result. So here we have get user data. So we will be consoling it. So just we will see that okay, user data, user dot name will be there. It will print and it will return user. As this dot then is returning something that will be consumed by the next then, we can write multiple then, as we want to do something from the above result. We got the user, so we'll just printing the email here, and if there is any error, we'll just consoling it. So this is how we write dot then dot then dot then. Okay, why this simulation was there? Just to understand that this then will wait till this line is executed, and it will get the resolve either or a reject as a response, and then we will be doing here going here. Yeah, now we see the -1, and it will be going into catch. as the here you saw that okay, rejection will be going. So rejection is giving a new error, so it will be coming here in the catch block. So we caught the error dot message will be printed. Now we have promises chaining. So each dot then can return a value or a new promise itself. This is how a chain of dot then happens. Here we return the get order user ID. Here also we return something. So these itself is kind of returning a promise. So this dot then will be executed when this is completed. So this is for wait and go, wait and go. So you have some task, you have done this, then you have put then. So this needs to be executed first. It may take 1 second, 2 second, 3 second. This line will wait till this promise is executed, completed, and the result will be shifted into the parameter of dot then. Again, it could pass a promise itself, and again the next dot then will wait till this is executed and we have something to process. So this is dot then chaining. So this is how the dot chaining look like. Now we have Promise.all and Promise.race. So let's suppose you need to make multiple API calls in parallel. So you want to fetch users also, you want to fetch products also, you want to fetch orders also, but in parallel. So first what you wrote, this fetch this API, and you have not written anything like I'm calling or waiting or anything. So it will be just a promise. So P1 is just a promise here. See, if I hover on the P1, we will see promise as a response is the return thing. Similarly, P2, P3, and promise.all will have an array of promises. What promise.all says? It says that I will wait till all the promises finished executing. So, yeah, here waits for all to finish, fails if any one fails. So, this is for all. So, here we have P1, P2, P3, it all be executed, and in the dot, then we will have the result of P1 in the users, P2 in the products, and P3 in the orders as after execution, as the response are getting in the sequential order as the promises are. This will be printed or cached, whatever is happening. If any of the promises failed, that will be stopped there and that will be cached. And we have promise.race. So here resolve or reject whichever comes first. So it's kind of a race. So this is a new promise, resolve set timeout fast as 1 ms, and here we have 5 ms. So here we have it will take higher time, so that's why the print will be happening as winner as the fast. So it will just stop at the first success or failure. So promise.race is used for that. Now we have some notes, you can refer this. Now we have section 4 as async and await. So when we define a function and we put async in the initials as the first, so async and await. So async await is the modern way of writing async code. It is built on top of promises and it does not replace them. It makes them easier to read and write. Async await makes your async code look and behave like synchronous code. So if you go, for example, if you use promise, it feels like you are texting someone that when you are done, just let me know. And if you are using async await, it feels like you are in the same room and you are just saying that I am here. When you are done, when you are finished, we will do something, or I will know. So in async await, it most like looks more good and easy to understand. So that's why it's more preferred. So in the callback, we have seen that nothing is in our control when the process started. This will go by and in the dot then we have seen something like dot then and so on. So this will go on as it is, and we will just print everything, so you can have some control and we can print, or we have some checks and we can stop here or something we can do. But it's also look very long code kind of thing. And we have async and await. So here it looks like this: constant response equals await. Just wait for the response and fetch some URL and close. So this will return a promise, and this will say, I am waiting, just give me the response. It will give you the response here, response, and later you can do something like process it or something. You can just perform something here. So here you see just a one line of code, fully detached. You can do any operation later or sometime, or you can just write something console in between, and later you can go and you can use this response. So it is fully detached, just one line of code, constant or let whatever, and you take a response of this API call and you are done. So this is the difference of callback and dot then and async await. So promise is the, so this is the same operation and could be wrote in three ways. So first one is callback, and the old way we could just get user and we can pass a function of console dot like user dot name. So we can pass a function in the callback. So now we have way two, which is promises. So just we write get user and we know that this is a promise and we put a dot then. So whatever the response will be there, we'll be using that. So it will be executed, then only this will be executed. And now we have way three, which is the cleanest, writing async await. When we write await here, we need to provide async for this function. We need to make this function asynchronous in order to use this await function. If we remove this, then the await will be not valid for this function. It will throw error that okay, you are using await in and we are not defining this function as async. So that's why we need this. So you have three ways of writing this function, and this is the way we will be using. And yeah, so let's go for the next thing, the async await keywords. Two rules. First is any function that uses await must be declared with the async keyword. So any function that uses await must be declared with the async function. Second, await pauses the function and waits for the promise to resolve or reject, and to resolve before moving to the next line. So it gives the synchronous feel in a asynchronous code. So here we will be waiting till the response is here in the user, then we will be printing this. It is not like if we have console in the previous, we have seen that if we have something that needs to wait and it will be going into web APIs and we will be moving forward as we seen previously. So here we have await. This changes the picture. It says that JavaScript will, here it will wait for that okay, we will be waiting that okay, when the response is coming, then only we will execute further. So this is how async and await works. And this also doesn't block your server that okay, I have written one async await and we will be not able to process other things. So it is not like that. And here async keyword makes the function return a promise automatically. If you see hover over here, it just shows that it returns a promise with a string in it, as we have hello here. If you change it, put it 1, and if now I hover, it says promise with the number. So it works like that. So this async makes automatic change that okay, this function will be returning promise. Now it returns string, but if I add async here, then it returns promise. Now we have greet dot then message console dot log. So even though we have written a plain string, async wraps it into promise automatically. So here it will be wrapped into promise. Now we have function delay, and we are passing how much we want to delay this. So here in the delays, if the function is called, we will be returning promise from this function. So whichever function is calling this will expect a promise. So here we'll see that promise is returning any. Any is used when we do not know what is the response type is. So here we are returning some set timeout with the resolve, that it will resolve, not rejected. So we are returning resolve with some ms, that okay, whatever you are giving me as 1000 ms, so we are taking that and we are returning you with the set timeout. So this will wait for 1 second and this will be printed, and then again it will wait for 1 second and this will be printed. As we have await here, it will be not going for the next row, then next row, and then this, because we have await. So JavaScript will not execute the next line, it is waiting here. So technically, why await is used? When we need the response from this whatever execution promise to do the process later, so we will use await, so that we will fetch some API and then we'll do some calculation and then return to the front end. So there we use await. Yeah, now we will go for error handling with try catch. So with promises, you use dot catch, and with async await, use try catch. Okay. The same error handling we covered in the part 4. This is the like natural thing. This is very common thing to do. Try will start from here and it will go in the catch, and again finally here we are. This is how we fetch data from some API. We write await fetch, then we write the URL, and response is here. If response whatever we got is okay, else it will throw error that HTTP response was wrong or something. We will be covering this in project, so you do not need to worry. Just you understand how the code is written. So how we write response equals to await, as it says wait for the response from server. So if you are calling any server for a response, it will not give you just in a sudden quick instance. It will go into database and check the data, it will give you the response. So it takes some slight of a time. Also it takes some slight of a time to reach the server to ask this question that okay, please could you give me this response. So this much time is there. It is very minute, that could be very small, that human will not know this, but the program that is running at that rate will know. So that's why we need to put a await, that okay, JavaScript wait here, let me get the response, then I will do it parse, and we will have user, then user dot name, I will print and return the user. So this will whatever the business I need, and I will write that. So this is how we get the user. Now we have a watch out that always wrap await calls in try catch. If you do not and the promise rejects, you will get an unhandled promise rejection error. In React, unhandled error, async errors can crash your components. So that's why we use. So you will see that okay, how these things are given in React, and you need to anyhow use try catch. That is a very good practice to do. Now running promises in parallel with async await. So you can just write slow version with user, await fetch user, products, fetch products. So it will first fetch this user, then it will fetch products, and we will do the further process whatever we need for users and product. Or we can use Promise.all, and we can execute both of the promises in parallel, and whichever takes the max time is the average whatever times we need. So let's suppose we have multiple API calls, each taking 2 seconds, and we are calling it in parallel by using Promise.all. So the whole time will be 2 seconds. But if we are calling sequentially 1 2 3, then it will be like okay, we are calling 2 APIs in addition. So it will like 10 seconds. Let's suppose there are 5 APIs, so it will take 10 seconds. But here the same 5 API will take only 2 seconds if we run them in parallel using Promise.all. Now we have section 5 as fetch API. So this fetch is by default present in Node also, that you can just make API call using fetch. And if you want to use a library which is Axios, it is mostly the standard library that is used to call any API call. So we use Axios for that. So to understand this, first we will check what is API. Let us make sure everyone understands what API is. This is important because freshers often know the code but struggle to explain the concept, that what is API and what, if you know that okay this is API calling but someone asks you what is API, then you could say by example that okay, an API is like a waiter in a restaurant. You, the front end, do not go to the kitchen, the backend database yourself. Like the kitchen is the backend and you are the front end as a user. So you give order to the waiter that okay, just these are my stuffs that I need to order, and the waiter takes your order to the backend, which is kitchen, and that is being prepared. And when waiter comes with the food, you get that your food. And this is how the API works. That API is the waiter. It takes your ask to the backend, and the backend performs some task, and it gives the kind of result or response to the API and delivers to the front end. So this is how the API is there. And the most common type is the REST API. Currently, just you know that REST API is the common. REST API is kind of set of rules. If those rules are followed while writing the API, it's called REST API. There is another SOAP API. So, but the commonly which you will be using is mostly REST. And what happens? You send a HTTP request to URLs, endpoints. The server sends back you JSON data, and what you can perform. So this is you with the phone, and this is the satellite, or let's suppose this is the server, and you can get some data, your profile and all those things. Now you want to just do some addition, like you want to create a new account. So you just do a post call that is for that. Then you want to put, so it is updating the existing data. You want to just update existing data, then it's kind of put. And you want to just update your phone number, so that is patch. And now you want to delete your account, so delete. So these are the types of API call that happens. So this is called HTTP methods. Okay. Although while you are writing any API, you can just make all API post also, and you can just do all those things. But if you follow these things for each kind of task, then it will be more better and standard practice. So in industry, in the big companies, we follow these standards, so that with a smaller like with a kind of smaller understanding of the code also, we will know that okay, this is get API, this is post. What it does, we will have an idea by this just the level, that we will know that okay, this is patch, so it will not be deleting anything, it will just to update some small, like few numbers of fields only. So this is the basic get request. The fetch function is built into the browser. It makes HTTP request and returns a promise. So if you see how we fetch, and we put a URL here and dot then, and we get a response. If you want to test some APIs, so free API So if we want to have, we are getting, so we have these data. We did a get call here. So these are the possible stuffs. We have post, we have put, patch, delete. So this is you can just use from the free resources for now. So here we have fetch, we are fetching, and then the response is here. Status we are printing okay as true, and we return response.json. Then again this user is here, so we will use user.name, user.email. We have parsed it, so that's why we can access it. Otherwise, so if you do use of Axios, this step will be removed. Axios will handle this step itself. And now here we have some watch out option that fetch only rejects the promises for network errors, no connection, DNS failures. A 404 or 500 responses does not cause .catch to run. Let's suppose your server is down or you have a kind of no access or not found. So these will be not going into .catch. So you need to check manually. You need to check the response.ok. So then if it is not okay, then throw the error. So that's why. Now we have fetch with async await. We have a function calling here we have display user is being called. User await get user one. So we want to get the user. So let's see where the get user is. Okay, here it is get user. We have got the ID as one. Constant response, we have provided the ID here one. So we have some response here. We will check if the response.ok is true, then it will not go inside it. If false, then it will throw a error and it will land into, here we have catch block. So it will land into catch.error and it will print the console.log error and it will throw error again. And if gives true, then we will go for user from the JSON and we will return user, and we will have the user here and we will print it. So simple, just we are using await here, and in the previous we have used how dot then could be used. Now we have post request. What changes into post? In get we do not pass any element to the backend. In post we pass element, like we have some user data from where this function is called create user. So here create user is called with name, email, city. This is passed in this function, and here we gave those data into the body. The server will receive that data and it will be saved into database. I will explain just what happened here. First just look into it. So again we will get a response. If there is any error, it will throw error. If not, it will just console and will go on. So in get we just ask for read only info. We get the information. In post, let's suppose we filled some data like email and password, then click login. So this data needs to be sent to server for verification. So here we used post call to send that email and password in the body. So that is body. We will look more what is body, what is param, these things. So if we are passing something in body, so that is this email and all those fields at the time of login. I hope you have some idea. Now you know the basics of how do we call a backend. So let's see uh, in reality how we let's build some project user dashboard. We call the JSON placeholder API to fetch the list of the users. We will display them as cards, and we show landing state while data is being fetched, and we show an error state if the fetch fails. We add some search filter by username or something in the, this will be a kind of real world pattern how you build a React uh, kind of basic, and later we'll build exact thing in the React also. So let's build user dashboard HTML. So I will be writing the HTML code quickly, and you can just have a reference for here, and we will be writing the JavaScript code uh, on the screen. So this is the HTML code. I will copy the path and go here, and we have user dashboard, search by name, and loading user is here. So it is kind of all hard coded. We will have some JavaScript magic here. So we can do script, and let's start coding. So we have constant API URL equals, let's bring the Java placeholder, and here we will use users, and let all users empty array. So now we have a URL, all users array. Now what we will do? We need to call the API to get the response. So let's first build a skeleton function. So skeletons, we'll have a constant grid equals document dot query selector, and we will have an ID of loading users as, we will take the ID of user grid, and grid dot inner HTML equals array 6 dot, it is how we take a array and also fill the array with some elements. So it could be done like this, and in the array we will put some HTML. So we'll take div, close, open div, and here we will have some a design like class equals skeleton, which is coming from here, skeleton. Then the all array elements are joined. So this is kind of skeleton that we will have. We have an array element with the divs. Each array of 6 has a div, and it's kind of skeleton. So you will see how it looks later. For now, now you need to write why I am using has here. And if you have followed the previous video, you will know. So just comment down why I used has here before the user grid, and constant status equals document dot query selector. We have status, which is this, and now we have status and grid with us. Okay, to understand why we are writing this, let's first write a async function that we have read, and you need to have a look. Async function fetch users, users data equals await fetch. We have used API URL. Then we will do constant. No, we will check first if user data dot ok, then throw new errors. User eh, failed to fetch users. Okay. If we got, then we will do constant users equals await user data dot JSON. Now we will have a stringified response, and we will be doing render users. And as I said, we need to have a try catch. So we will use the try here and catch with error. Failed to call fetch user API. Okay. And we have not done anything as open, so we can also do one thing. Status okay, we need the status also. We can just do status dot text context equals error dollar curly braces. Here the error will be passed, or we can just do error dot message not try again and backtick. Here do errors. So fine. Now we have something, and also we can do status dot class name equals error, so that the status will be the class will be changed to error. Then document dot query selector use grid dot inner HTML equals empty. Now the grid will be empty. We will not see anything. Yeah, this name need to render users. Yeah. So now, as we see, we need to be calling this render users, and grid and status we have already. So we will check if users, as we got here, users dot uh, users dot length is equals to 0. So none user is there. So what we will do, grid dot text sorry, inner HTML will say no user found, and we can just put the paragraph here. So this will show the grid that okay, we do not have any user. Also we can do status dot text content equals 0 user zone and return. So this is the handling for the uh, 0 users. It could be skipped also, but yeah, if we have that knowledge that okay, if there are none user, currently we are listing, and let's say we refresh and we do not know why nothing is showing up. So right now we will have an idea that okay, no user found means the count of user that we are getting is 0. The API call was success, but we didn't get any user, so that's why we are having this response. So now we will have a better user experience. And status dot text context equals to showing if we have now users, then we can show that users dot length showing this much users and backtick. So this will be closed, and status dot class name will be nothing. Okay. Now the main thing we want to show grid dot inner HTML equals user. We will have a loop on a user dot map, and just take each user and make a HTML out of it as div class equals backtick. Oh, sorry, class equals card, and we will have h3, and here we will say user dot name, and h3 closed. So since we are doing a loop, so we will be producing this HTML cards for each user by just writing this much of code. And here we will be writing a p and class as email. Here we will put the user dot email, then close. Again we can do p and this. Here we can have user dot address dot city. How these things are coming, then you can just check these JSONs. It is different, so you can see if I write users. So here we'll see that each user have these data. I can go into address dot city. The same API I will be calling, so that's why I know where the data will be. And we have this also. Let's suppose we write address, and then we want website, so we can just take this and paste. Simple. And now after the map is created, we need to have a join without spaces, and it will be kind of whole string of uh, div, and so HTML will be created and we will be just putting it to inner HTML. So now we will have this, and yeah, we have render user fetch. Okay, here we have some. So I think it is closed. Try was here. Try closed. Catch closed. Okay, we also missed calling this function. Whenever we will be loading this fetch user, we will be showing a skeleton kind of thing where none of the response will be visible, but a false hope of loading will be visible. So not false, but truly a skeleton will be showing a hope that okay, the UI is loading. So just wait for a while. Let's format this. Now if I shrink this, now whenever the page loads, we need to call this fetch user. So we will go here and just refresh this. So if I can refresh, so that skeleton was there, and this is kind of bad. So let's see what is wrong here. We have fetch users status. We are having users here, rendered users, and rendered users is here. Users are checked. Text context is showing 10 results. That is also good. We looped on it for each user with the backtick. We have not closed the div also. We have missed the dollar sign. This, and the closing div is missed. Open this. Okay, now we have saved this and refresh. Nice. So we have the names, email, this is the website, and this is the city. Now we need to have something like search here. So let's build document dot query selector on what? On the search is loading users. Yes, here search input. So as this. So on this, we will put a search event, add a listener here. Add listener whenever some input is there, we take a event and we perform action on it. Constant query equals e dot, this is the input field, so we will know the value inside it. So now we have the value which was written, so we will do two lowercase and then trim. Hope you remember what these functions do. It converts to lowercase and it trims whatever extra spaces are there in front or end. Then we filtered users are all users dot filter dot sorry, inside this each user will be checked for what? User dot name dot to lowercase dot includes query. If any of the name have those characters, that will be filtered and it will be rendered. Filtered users. So if I refresh, it is here. If I type E, no user found, but we have E. Now let's again see what we have done wrong. We have missed a param here. Let's E. This all users is wrong. We are not set. Create on this. This is happening from users. So okay, we can change something. All users is passed, and now if we do yeah, now it's working. So just I'm using all users here. And so that's why I changed where we are storing the response that we got initially in all users. Earlier we had a single variable which was just passed. So the intention of defining this all user was the global scope for each function to the list of uh, users we got. So that's why I fixed that. And now we have this functional. And that is the JavaScript part 5 done. We have covered how JavaScript handles async code with the event loop and callback, and why callback hell is a problem, promises, and what they are, how to chain them by using dot then and promise.all, promise.race, async await, the modern way to write async code, and the fetch API, get, post, request, all the other methods that we have seen, post, put, and all those things, and checking the response by response.ok, handling errors by catch and throwing it, and it could be cached again. And we build a real user dashboard where we call the actual live API, uh, shown the skeleton, how the loading skeleton could be shown and handle errors, and also the search method was there, how we search in the existing response that we have. We could also search in the database, but we want that from the existing one, so we have done that. That is the part 5 of the JavaScript. And since now we have covered all the topics, we will be moving to um, React series. Everything we learned in the part 5 uh, feeds likely directly into it will lead you to the React series. It will you see how the connection of JavaScript to React is, and we will be learning about state using of use state, which uses destructuring and data fetching in React, all those things. So let's meet in the next video, and you can drop your comment of whatever questions you have or any improvement you need or anything. And yeah, like this video, and let's connect to the next.